Swarna Latha, Assistant Professor in the Department of Electronics and Communication Engineering. In today's lecture, we are going to discuss about the problems on joint distribution function and the marginal distribution function. In the previous lecture, already we have discussed about the joint distribution function of two random variables and n random variables. After that, we have seen the properties of the joint distribution function. So, what is a joint distribution function of two random variables x and y? For example, if x and y are two random variables, then the joint distribution function, distribution always represented by capital F. So, the joint distribution function of the two random variables x and y given by P of, P is nothing but here probability. Probability that the event such that the random variable takes x less than or equals to x and the random variable takes y less than or equals to y. So, this is called as what? The joint distribution function of two random variables x and y. Nothing but the probability of the joint event x less than or equals to x and y less than or equals to y. And so, this is the joint distribution function. So, after that we have seen the properties also. Now, by using this, you have to calculate the problem like they have given the joint probability mass function of two random variables x and y is given by pxy of x comma y is equals to 0.2. This is when x equals to 1 and y equals to 1. And when x equals to 2 and y equals to 2, the probability is 0.15. And when x equals to 3 and y equals to 3, the probability is 0.25. And when x equals to 4 and y equals to 4, the probability is 0.4. And for all the remaining values of x and y, it means except these x and y values, for all the remaining values, the probability is 0. So, what you have to calculate? You have to calculate fxy of x comma y. It means what? You have to calculate the joint distribution function of the two random variables. After that, you have to calculate what? Find p of 1 less than or equals to x less than or equals to x comma y is less than or equals to 2. Now, let us solve this problem. So, what they have given that? They have given that when x equals to 1, y equals to 1, 0.2 is the probability. When x equals to 2, y equals to 2, 0.15 is the probability. And when x equals to 3 and y equals to 3, 0.25. So, if you observe this, the type of random variable here is what? Discrete random variables. So, for discrete random variables, how can you write down the joint distribution function fxy of x comma y is equals to what? Sigma I, sigma j, p of xi comma yj into u of x minus xi into u of y minus yj. So, this is what for discrete random variables. So, for discrete random variables, how can you write down the joint distribution function fxy of x comma y is equals to what? Sigma I, sigma j, p of xi comma yj into u of x minus xi into u of y minus yj. So, what is this u of x minus xi and u of y minus yj? They are the unit step functions. How they are defined? So, what is u of x minus xi? That is equals to 1 only when x equals to xi and 0 otherwise. Similarly, what is u of y minus yj? So, u of y minus yj equals to 1 when y equals to yj and 0 otherwise. This is the joint distribution function of the two random variables. Now, what are the x values and y values we are having? X is 1, y is 1. The first one is what? fxy of x comma y is equals to p of x is 1 and y is equals to 1 into what? X minus xi. What is xi here? 1 into u of y minus yj. What is y1? So, yj is nothing but what? 1 plus what is the next x value? X equals to 2 and y equals to 2. Nothing but p of x equals to 2 and y equals to 2. So, p of x equals to 2 comma y equals to 2 into u of x minus 2 into u of y minus 2. Here sigma is nothing but what? Plus. What is sigma here? Sigma is nothing but plus. Next, what is x value and y value? 3. Therefore, plus p of x equals to nothing but 3 and y equals to yj. What is yj value here? 3. Into what? U of x minus xi. Nothing but u of x minus 3 into u of y minus 3 plus next x equals to 4 and y equals to 4. So p of x equals to 4 comma y equals to 4 into u of x minus 4 into u of y minus 4 that equals to fxy of x comma y is equals to. So what is p of x equals to 1 and y equals to 1? The probability that the random variable takes x equals to 1, y equals to 1, nothing but they have given us what? 0.2. Therefore, that equals to what? 0.2 into u of x minus 1 into u of y minus 1 plus. So when x equals to 2 and y equals to, what is the probability here? 0.15. Therefore, 0.15 into u of x minus 2 into u of y minus 2 plus, next what do you have here? Probability that x equals to 3 and y equals to, what is the probability they have given? 0.25. Therefore, 0.25 into u of x minus 3 into u of y minus 3 plus, so when x equals to 4 and y equals to 4, what is the probability here? 0.4. So plus 0.4 into u of x minus 4 into u of y minus 4. Therefore, so this is what? This is nothing but the joint distribution function of the given, the two random variables for the given probabilities. So this is the first bit. And what is the second bit you have to calculate? Find p of 1 less than equals to x less than equals to 2 comma y less than equals to 2. So what you have to calculate here? The second bit is what? P of 1 less than equals to x less than equals to 2 comma p of probability such that the x is taken from 1 to 2 and y is less than or equals to 2 and y is less than or equals to 2. So there is nothing but what? Probability that x takes from 1 to 2 and y takes from 1 to only less than or equals to 2. So here what is x values they are having? They are given 1, 2, 3, 4. See here what are the x values they are given? 1, 2, 3, 4. Whatever the y values they are given? 1, 2, 3, 4. For all the remaining the probability is 0. Therefore, what are the y values here? 1, 2, 3, 4. So y less than or equals to 2 means up to 2 you have to take. So x is from 1 to 2, nothing but you have to include 1 and 2. So you have to calculate the probability such that p of x equals to 1 and y equals to 1 and p of x equals to 2 and p of y equals to 1. So like that the values of x should be 1 to 2 and the values of y should be less than or equals to 2. Therefore you can calculate like p of x equals to 1 and y is less than or equals to 2 plus p of x equals to 2 comma y less than or equals to 2. That equals to what? P of x equals to 1. So y less than or equals to 2 means how many values it is taking? Y equals to 1 plus p of x equals to 1 comma y equals to 2 plus here what do you have? P of x equals to 2. Whatever the y value is up to 2, nothing but 1 and 2. So once you have to take y equals to 1, the other time you have to take x equals to 2 and y equals to 2. That equals to, what is p of x equals to 1 and y equals to 1? 0.20. And p of x equals to 2, y equals to 2 nothing but 0.15. Therefore, this is 0.2 plus x equals to 1, y equals to, you don't have. You are having only x equals to 1, y equals to 1, x 2, y 2. So you don't have x is 1 and y equals to 2. Therefore, this value is what? 0. So 0. And you don't have p of x equals to 2 and y equals to 1. Therefore, it is also 0. And p of x equals to 2 and y equals to 0 is 0.15. So what is the value here? P of x equals to 2 and y equals to 2 is 0.15. Therefore, what is the probability here? 0.35. So therefore, this is a probability such that the random variable x takes from 1 to 2 and y is less than or equals to 2. So like that you can calculate the joint distribution function corresponding probabilities by using the distribution function definition. And your second problem here is the joint space for two random variables x and y and the corresponding probabilities are shown in the table. So find and plot First one is what? You have to calculate what? Joint distribution function. Second one, you have to calculate the marginal distribution functions of x and y. And third bit, probability is such that the x takes from 0.5 to 1.5. And the fourth one, probability is such that x less than or equals to 1, y less than or equals to 2. And the next bit is find the probability such that x is from greater than 1 and less than or equals to 2 and y is less than or equals to 3. So what is the given table? They are given x, y values and given the corresponding probability. So when x is 1 and y is 1, the probability here is 0.05. And when x is 2 and y is 2, the probability here is 0.35. And when x is 3, y is 3, the probability is 0.45. And when x is 4 and y is 4, the probability is 0.15. And whenever you add all these probabilities, you have to get as what? 1. 0.05 plus 0.35 plus 0.45 plus 0.5. So the sum of all these probabilities should be equal. Nothing but P since the probability of the sample space is equal to 1. So therefore, what is the first one you have to calculate? You have to calculate the joint distribution function fxy of x comma y. So what type of random variables they are? They are the discrete random variables because x is taking 1, 2, 3, 4. And y is taken from 1, 2, 3, 4. They are the discrete values. They don't have any continuous range of values. Therefore, the type of random variables here they are given is discrete random variables. Now, for discrete random variables, what is the joint distribution function formula? Sigma I, sigma j, p of x equals to xi, comma, y equals to yj into u of x minus xi into u of y minus yj. Therefore, fxy of x comma y is equals to. So, what is the first x value? 1. And what is y value here? 1. Therefore, we can rewrite this as what? P of x equals to 1 comma y equals to 1 into u of x minus 1 into u of y minus 1 plus. Next, what is the x value? Xi value 2. Next, what is the yj value? 2. Therefore, P of x equals to 2 comma y equals to 2. This is 1. Okay, into u of x minus 2 into u of y minus 2 plus P of what is x value, y value 3 now. Therefore, x equals to 3 comma y equals to 3 into u of x minus 3 into u of y minus 3 plus P of what is x value and y value here now? 4. So, P of x equals to 4 comma y equals to 4 into u of x minus 4 into u of y minus 4. Now substitute the corresponding probability. X equals to and y equals to the probability is 0.05 and here this is 0.35 and here this is 0.45 and here it is nothing but 0.15. Now write down fxy of x comma y is equals to, what is the first probability here? 0.05. So 0.05 into u of x minus 1 into u of y minus 1. And what is the next probability here? 0.35. So therefore 0.35, this is when x value 2 and y value is also 2 plus the next one is 0.45. So plus 0.45 into u of x minus 3 into u of y minus 3 plus what is the next term? When x is 4 and y is 4, the probability is here 0.15. Therefore, 0.15 into u of x minus 4 into u of y minus 4. Therefore, this is the answer for the first bit, A bit. And what is the B bit they have given? We have to calculate what? The marginal distribution functions of the random variables x and y. So, we have to calculate what? The marginal distribution functions of the random variables x and y you have to calculate. So, what is the marginal distribution function of the random variable x? Nothing but fx of x is equals to. So, it's nothing but what? P of x less than or equals to x comma. If you want the marginal distribution function of the random variable x, we have to keep y as infinity. Nothing but what? fxy of x comma infinity. That is, this is from, you can write down from the properties of the joint distribution function. Therefore, what is the marginal distribution function of the random variable x? In the joint distribution function, if you keep y equals infinity, then you are going to obtain the marginal distribution function of the random variable x. So already I have written the joint distribution function for the random variables x and y. So in this, what you have to keep? You have to keep y equals to infinity. Then you can write down this as what? fx of x is equals to fxy of x comma infinity. That equals to what? 0.05 into u of x minus 1 into u of infinity minus 1 plus 0.35 into u of x minus 2 into u of infinity minus 2 plus 0.45 into u of x minus 3 into u of infinity minus 3 plus 0.15 into u of x minus 4 into u of infinity minus 4. So that equals to, what is u of infinity minus 1? Nothing but u of infinity. Therefore, 0.05 into u of x minus 1 into, what is u of infinity? So what is u of x value? That is 1 when x is equal to 0. And 0 for x less than 0. Only for negative values it is 0. For all the positive values up to infinity, infinity's value, that value equals to 1. Therefore, what is u of infinity value here? 1. And u of infinity minus nothing but u of this value is also 1. Therefore, we can read this as what? 0.05 into u of x minus 1 plus 0.35 into u of x minus 2 plus, and here also this value equals to 1 and u of infinity minus 1 nothing but u of infinity. What is u of infinity? From this greater than equals to nothing but from 0 infinity that value equals to 1. Therefore, this is 1. Then you can write this as what? 0.45 into u of x minus 3 plus 0.15 into u of x minus 4. This is what the marginal distribution function of the random variable x. And similarly, what is the marginal distribution function of the random variable y? So if you want the marginal distribution function of the random variable y, what you have to do? You have to keep x as infinity in the joint distribution function. Therefore, fi of y is equals to what? So in this fxy of the joint distribution function, you substitute now x as infinity for getting the marginal distribution function of the random variable y. Then how can you get an obtain here? 0.05 into u of, see, infinity minus 1. What is u of infinity minus 1? U of infinity. What is u of infinity value equals to 1. Therefore, 0.05 into u of y minus 1 plus, next one is what? 0.35. This value equals to 1. If you keep x as infinity. Therefore, 0.35 into u of y minus 2 into u of y minus 2 plus, and here also if you keep x as infinity, this value equals to 1. Therefore, 0.45 into u of y minus 3. So, 0.45 into u of y minus 3 plus, the next one is 0.15 into u of y minus 4. So, therefore, this is what the marginal distribution function of the random variable y. Next, what is the C bit here? You have to calculate what? P of the find the property such that 0.5 less than x less than 1.5. So, P of 0.5 less than x less than 1.5. What is the x values they have given? They have given x values 1, 2, 3, 4. What about the y values? 1, 2, 3, 4. Therefore, here the x values 1, 2, 3, 4. And whatever the y values, 1, 2, 3. For the remaining, the probability is 0. Therefore, so from 0.5 to 1.5, it means what? Which value you are going to obtain? 1. And therefore, it's nothing but what? P of x equals to 1. So, now what is P of x equals to 1? Nothing but y value may be anything. So, see here, P of x equals to 1. Nothing but your y value may be anything, but in P of x equals to what is the value here? The probability is 0.05. Therefore, nothing but P of x equals to 1 and y may be anything. So, what is this value is equals to 0.05. And what is the next bit here? Find P of x less than equals to 1 comma y less than equals to 2. So, what you have to calculate here? Find P of x less than equals to 1 comma y less than equals to 2. So, P of x less than equals to 1 comma y less than equals to 2. So, it means x is less than or equals to 1. Less than 1, you don't have any value. So, have only 1. Therefore, it's nothing but P of x equals to 1 and y is less than or equals to 2. Nothing but x equals to 1, y less than or equals to 2 is nothing but you're having 1 and 2. Therefore, y equals to 1 plus P of x equals to 1 comma y is equals to 2. So, what is P of x equals to 1 and y equals to 1? The probability from the given table 0.05. But you don't have the probability such that x value 1 and y value 2. This value equals to 0. Therefore, what is the answer here? 0.05. Next, what is the E bit? Find the probability such that P of 1 less than x less than equals to 2 comma y less than equals to 3. So, what is the E bit here? P of 1 less than x less than equals to 2 and y less than equals to 3 comma y less than equals to 3. So, 1 less than x less than equals to 2. Therefore, what is x value? X value should be greater than 1 but should be less than equals to 2. Therefore, what is x value here? 2. And y is less than equals to 3. Nothing but what is y value here? 1, 2, 3. Now, write down here. What is x value? It is taking only one value 2. And what about the y values? So, y equals to 1 and P of x equals to 2 comma y equals to 2 plus P of x equals to 2. X is taking only single value. And what about the y value here? Y equals to 3. That equals to. So, P of x equals to 2 comma y equals to 1. So, what is P of x equals to y equals to 1? It is 0. Plus P of x equals to 2 and y equals to 2. What is the value of x is 2 and y is 2? The probability nothing but 0.35. Therefore, this is nothing but 0.35. And x equals to 2 and y equals to 2 don't have. Therefore, it is 0. Therefore, what is the answer here? 0.35. So, like that, you can calculate from the given problem, to give the probability mass function, you can calculate the joint distribution function, the marginal distribution function, as well as can calculate the probabilities of the given events. What is the next problem here? The random variables x and y have the joint distribution function. It means they have given the joint distribution function. So, you have to calculate what? The distribution function of the random variables x and y, and then you have to calculate the probabilities of the events. What is the joint distribution function they are given? That equals to what? 1 by 1 minus x square into 1 by 1 minus 1 by y square when x is greater than 1 and y is greater than 1. Okay. And it is 0 for all the remaining values. So, what type of random variables here? The type of random variables they are given is what? The continuous random variable, because they are given the range here. That's why the random variables are continuous random variables. So, what you have to calculate now? You have to calculate what? The marginal distribution function of the random variable x. There is nothing but what? Fx of x. How do you calculate the marginal distribution function of the random variable x? By keeping in the joint distribution function y as infinity. Therefore, fxy of x comma infinity. Therefore, fx of x is equals to, they have given fxy of x comma y. So, you have to get the marginal distribution of x, you have to keep y as infinity. Then what can happen here? 1 minus 1 by x square into 1 minus 1 by y as infinity. So, what is infinity here? Infinity square. This is for when x is greater than 1 and 0 otherwise. So, that equals to fx of x is equals to 1 minus 1 by x square into. So, what is 1 minus 1 by infinity? What is 1 by infinity? 0. So, 1 minus is nothing but what? 1. Therefore, this is nothing but what? 1 minus x square when x is greater than 1 and 0 otherwise. Similarly, what is a marginal distribution function of the random variable y? So how can you obtain here? By keeping x as infinity in the joint distribution function, you are going to obtain the marginal distribution function of the random variable y. Therefore, fi of y is equals to. So what is fxy of x comma y? This. So in this, what you have to keep? You have to keep x as infinity. Therefore, what can obtain here? 1 minus 1 by what is x value here? You have to keep as infinity. So infinity square into 1 minus 1 by y square when for what values of y? When y is greater than 1 and 0 otherwise. So that equals to what? Fi of y is equals to. So what is 1 by infinity value? 0. 1 by infinity is nothing but 1 by infinity. 1 by infinity is 0. So 1 minus 0 nothing but what? 1. So 1 into 1 minus 1 by y square is 1 minus 1 by y square when y is greater than 1 and 0 otherwise. So this is the first bit. And what is the next bit they have given? You have to calculate what? You have to calculate the probabilities of the event when x is less than 2 and y is less than equals to 4. And when x is greater than 3 and y is greater than 2. So first one is when x less than 2, y less than equals to 4. So P of when x is less than 2 and y is less than or equals to 4. So x is less than 2 and y less than equals to 4. Therefore, what is fxy of x comma y is nothing but what? P of x less than equals to x comma y less than equals to y. So here in place of x you have 2, in place of y you have 4. Therefore, this is nothing but what? P of x less than 2 and y less than equals to 4. Nothing but what? fxy of. So in place of x you have 2. In place of y you have what? 4. So fxy of 2 comma 4. So in the given distribution function, you have to substitute x as 2 and y as 4. Then you can calculate as what? 1 minus 1 by 2 square into 1 minus 1 by 4 square. It is nothing but what? 1 minus 1 by 4 into 1 minus 1 by 16. That equals to 3 by 4 into 15 by 16. That equals to what? 45 by 64. So this is the answer for the probability such that x less than 2 and y less than equals to 4. And what is the next one they have given? Find the probability of the event x is greater than 3 and y is greater than 2. What they have given that? Probability such that x is greater than 3 and y is greater than 2. That is nothing but what? How can you write down x is greater than 3 and y is greater than 2? Nothing but what? 1 minus p of, can write down like this, x less than equals to 3 comma, x is less than 3 and y is less than equals to 2. X should be greater than 3, nothing but greater than nothing but 3, 4, 5, 6 and so on. Greater than 2, nothing but 3, 4 and so on. Therefore, you can write down as what is the total probability? fxy of infinity comma infinity equals to 1. The total probability equals to 1. Therefore, you can write down this as what? 1 minus p of x less than equals to 3 and whatever the y value should be less than equals to 2. Therefore, you can write this as 1 minus fxy of, now in place of x you have 3, in place of y you have 2. So 3 comma 2. That equals to 1 minus. So in given distribution function you have substitute x as 3 and y as what? 2. Therefore, you can write down this as what? 1 minus 1 by 3 square into 1 minus 1 by 2 square. That equals to what? 1 minus. So 1 minus 1 by 9 into 1 minus 1 by 4. That equals to 1 minus. So 8 by 9 into 3 by 4. That equals to 1 minus 24 by 36. That equals to 36 minus 24 is what? 12 by 36. Or else can write as what? 1 by 3. So like that, for the given distribution, for the given random variables, you can calculate the marginal distribution function and you can calculate the joint distribution function and even you can calculate the probabilities for using the definitions of the joint distribution function, and their corresponding properties. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.